So, now coming to the types of multimedia network applications, we all know that we are interested only in three types of multimedia network applications. In fact, we have classified the multimedia network applications as of T types. What are they? They are just streaming stored audio or video, conversational voiceover or video over IP, and streaming live audio or video. Unfortunately, many of us don't even know the definition of what is video streaming or what is a conversational voice over IP. Now, what else? We don't even know how to define live audio or video over the internet. So many of you made lot of mistakes in your exam papers. But anyway, right now we are not here to define just what is streaming video or audio. Instead, we are going to talk about the most important properties that are needed for this application to be a success. When we are trying to stream audio or video, we think why we should work this hard, why we should understand all these properties. Uh, we have a TV that is available, but today we cannot imagine a world where we can live without YouTube. Who has got the time to sit in front of the TV and watch your favorite channel for hours together? You all are comfortable in watching our favorite channel over YouTube with your laptop or your mobile phone. Now let us see what are the properties of streaming stored audio or video. When I just talk about it, streaming video, I emphasize on the word stored audio and video. So, to keep our discussion concrete, we focus on stored streaming video. So, which typically combines, when I say video, I mean video as well as audio. So, in this class of applications, the underlying medium is a pre-recorded video. When I say stored, I'm not doing it right now, but instead, someone has recorded the video and it is stored somewhere. Uh, the video could be a movie, a television show, or maybe a pre recorded sporting event, or maybe an educational class also. So, we all had live classes during the corona time. All the videos that they supplied was stored videos, a pre-recorded video which some user has generated. Nowadays, as we already discussed, YouTube is a boon to all of us because if you wanted to have a channel of your own, you don't need to have your own infrastructure because we can supply the pre-recorded content to the YouTube. Now, these pre-recorded videos are placed on servers and users send requests to the server. So if you want to watch something on YouTube which is already pre-recorded and stored, maybe a Udemy class or maybe a class that is conducted by your own teacher or maybe some very old movie, what we need to do, whether it is a very old movie or whether it is a pre-recorded class or whether it is some pre-recorded video of some musician, what we need to do is we have to mention the name of the video that we want to watch and send a request to the YouTube server. So whether it is YouTube server or Netflix or Hulu or Hotstar, for everything I need to select the website and send a request to them saying that so and so video I would like to watch. By some estimates, streaming stored video makes up 50% of the downstream traffic. Why is it a downstream traffic? Because when I send a request, my message doesn't have any video in it. When I send a request to the YouTube, it is a YouTube server which searches amongst all possible videos that it has. उनमें से जो वीडियो मुझे पसंद है वो वीडियो का जो वीडियो फाइल है वो मेरी रेस्पॉन्स के अंदर डाल के वो वापस भेजेगी. कैसे भेजेगी? पूरा वीडियो भेजेगी ना, एक एक रेस्पॉन्स ऑब्जेक्ट में इस वीडियो का छोटा सा हिस्सा डालकर भेजेगी. So now, here we need to understand a few words. The first thing is streaming. Now, streaming is not downloading. In a streaming stored video application, the client typically begins video playout within few seconds. Why few seconds? Because my request has to reach to the server should search for its video, and if it has one, it responds by sending the video to me. So all this takes only a few seconds. Whether YouTube is in America, if you want to watch some Hollywood movie, I know sometimes the request has to go all the way to America. In that case, few seconds की जगह पे few minutes लगेगा. If the video is somewhere in the nearby cache, which some of my friend has already watched last night, and it must be available in some cache, which is very near vicinity. So I just start the playout within few milliseconds. So time delay is dependent on how far my request has to travel. So, but some request has to travel to the server and I get the response back. So therefore I have a delay of few seconds. After few seconds, it begins receiving the video from the server. Why it begins receiving? Because the first response that I get will not have the complete video. It will have only a part of it. Now this means that the client will be playing out from one location in video while at the same time it is receiving later parts of the video. Now remember, the later parts should be received in such a way that I don't find any delay between what I am watching and the next bit of it. Sometimes it's very irritating or frustrating because I watch a bit, I have to wait for few seconds, then watch the next bit, then wait for few seconds, then watch the next bit. All this is really irritating. The user should not even know that the video is coming in parts and parcels to me. The delay between the first bit and the second bit should be minimal, that I don't even believe that some delay is occurring, and should have a feeling that I'm watching the video continuously. This technique where while I'm watching, the later parts of the video are being received by my host is called as streaming. Now streaming avoids download. I don't need to bother about offering many more resources for storing my favorite videos. All that headache is taken care by the network and the server. Now the storing part of it is taken care of by the server. So it is a server which stores the entire video file. Now the next thing is, in streaming video applications, apart from streaming in parts and parcels, I also has some user interactivity in this kind of applications, because the media is pre-recorded. So therefore, suppose if I miss something while I had a phone call when I'm watching the video, I can always play back the video again. So I can forward it. If I don't like some advertisement or some dialogue, I can forward my video. I can backward my video, I can fast forward something, and so on. And all the activities that happen in case of a CD can also be done in case of streaming application. Because this is a recorded video, I can always send a request back saying that I want the previous bit of it. If the bit is available in the nearest cache, I get it off. Sometimes maybe backwarding or forwarding might take a little time because I know I need to get that particular part I would like to watch. But I can always forward and backward. There is some interactivity. The time from when the user makes such request until the action manifests itself at the client should be less than a few seconds for acceptable responses. Now, coming to next feature that I want in the video streaming is, I need to have a continuous playout. I cannot bear the glitches in the video. Once video playout of the video begins, it should proceed according to the original timing of the recording. Now, वीडियो का एक पर्टिकुलर स्पीड एंड रेट रहता है, उसी रेट के अनुसार जब हम लोग वॉच करेंगे, आई विल नॉट सी ग्लिचेस इन द वीडियो. अगर रेट पे कुछ तब्दीली होती है तो बीच में glitches आते हैं and I can clearly see that something is going on at the back. I think I have a very bad internet connection and I hate it. So therefore, data must be received from the server in time for its playout at the client. Otherwise, users experience Video frame freezing. What is freezing? I look as if the picture बदलता ही नहीं है. Next picture आने के लिए काफी वक्त ले रहा है. That is called frame freezing. When the client waits for delayed frames or frame skipping, sometimes it skips the frames. Next वाला scene नहीं दिखता. दो scenes के बाद third वाला दिखने लगता है. That's called frame skipping. क्यों? I think पैकेट लॉस इसमें भी होता है. The next वाला वीडियो का बिट जो है शायद it got lost. And by then the time for the third bit has come up and वो दिखने लगता है. So therefore there is a frame skipping. Maybe पैकेट लॉस हो गया. And इसकी वजह से उसने बोला टाइम आ गया, so therefore let me skip though packets which are already lost, because in this kind of application it is a real-time application. We also should bother about the time constraint that it has. So therefore TCP का जो पैकेट लॉस का मैनेजमेंट जो होता है और फिर से वही चीज अगर लाना शुरू करे तो आई विल जस्ट बी वेस्टिंग अ लॉट ऑफ टाइम एंड द वीडियो में कंटिन्यूस प्ले आउट का डिस्टर्बेंस होता है. सो देयरफॉर इफ एक दो पैकेट्स अगर फेल भी हो गया उसको स्किप कर दिया और नेक्स्ट वाला दिखाने लगती है मुझे. And the video bits are called frames here, which is by far the most important performance measure for streaming video is average throughput. वीडियो चलने के लिए थ्रूपुट चाहिए. व्हाट इज थ्रूपुट? मिनिमम स्पीड, मिनिमम बैंडविड्थ. अगर वो नहीं है तो मेरा वीडियो का जो बिट्स एंड पार्सल्स है वो टाइम पे मेरे पास नहीं पहुंच पाएंगे एंड आई कुड सी video freezing, frame skipping and things like that. So in order to provide continuous play out, the network must provide an average throughput. जब मेरे नेटवर्क में इतना थ्रूपुट नहीं है, I don't think I can conduct a streaming application. See, today we have smart TVs and all. जब तक my internet company doesn't promise me a minimum throughput, I don't think I can enjoy the smart TV. So now, how this is happening? Now, sometimes you cannot always believe in the internet company and say that it's always going to offer the minimum bandwidth. No, the bandwidth or the speed varies over the whole day. Yeah. So, but most of these applications they use some intelligent techniques. As we said, they all keep various rates of encoded video. Now, depending on the kind of bandwidth that we are right now receiving, it adapts to that particular video rate. There's also something called buffering. It does prefetching. मानो मुझे इस सेकेंड 10:10 पे वीडियो चलाना है, so it tries to fetch 3, 4 or 10 frames before I could play the first frame and it buffers it. This is called buffering and prefetching. We'll study this one in detail later. Now it is possible to provide continuous play out even when the throughput fluctuates. That's called as adaptive video encoding. It's called as adaptive video rate. For many streaming video applications, pre-recorded videos is stored on. You must be saying, yeah, YouTube बहुत बड़ा website है. It just stores Hollywood, Bollywood, Tollywood and every भाषा का videos. It stores the classrooms also, online classrooms, online teaching websites. जितने भी videos है, serials है, गाने हैं, सारी चीजें store करती है. तो बहुत डिले होता होगा हम लोग जो मांगते हैं वो देने के लिए. But exactly ऐसा तो नहीं होता. What it does is it maintains what is called as content development networks. And there's also a kind of smart ways of management. Most of the times if we are in Maharashtra, we know that people will be demanding either Hindi movies or maybe they are very interested in Marathi movies. Very little crowd will be interested in Telugu or Gujarati or some other languages. If you are in at least Mumbai, people must be asking Telugu or some other languages. If you are in your village, no one will be asking Telugu or some kind of Tamil or Gujarati movies. All the community must be relying on either Marathi or maybe a few Hindi movies. Now, Hollywood तो बड़ी दूर की बात है. So therefore, these websites which maintain the video streaming applications, they are going to develop their own content development networks. They have lots of distributed servers, and the content that they are going to store is not going to be too big. Depending on locally what kind of contents people demand, they just maintain or store only those videos, and anything beyond that, if one or half person demands, only that request is going to travel very far. So content development network rather than a single data center. एक डेटा सेंटर किसी बैंगलोर में पड़ी है और सारे रिक्वेस्ट बैंगलोर तक जाके वापस आना है, तो वी हैव टू मच ऑफ ट्रैफिक. So one tricky and intelligent way to reduce the traffic in one server is to maintain a content development network. महाराष्ट्र या मुंबई में जो people are interested, these video companies, they do a lot of research, for over 4 years or 5 years का डेटा लेते हैं, और उनके तजुर्बे में लोगों ने क्या मांगा है, उसी का कंटेंट डेवलपमेंट नेटवर्क दे जस्ट मेंटेन. Now if you have in Andhra, they must be seeing Telugu movies and Hindi. So उसी का कंटेंट वो लोग मेंटेन करेंगे और मोस्ट डिमांडेड मूवीज का कंटेंट रखेंगे, एंड जो नॉन डिमांडेड है शायद उसका सर्वर थोड़ा दूर रखेंगे. So they are also P2P video streaming. There's another intelligent way is use a P2P network. वीडियो पूरा एक ही जगह से मिलने की जरूरत नहीं है. वीडियो का टुकड़े जो है अलग अलग peers में स्टोर करते हैं. Usually hosts here are peers. So when I try to demand one video, what the internet does is it tries to look for pieces that are available in the nearby peers. मानो कल रात को किसी लड़के ने कोई वीडियो देखा है कि यह थोड़ा सा देखा और छोड़ दिया, किसी दूसरे लड़के ने वही वीडियो का दूसरा हिस्सा देखा है. He was watching the video some time back and उसका जो बचा हुआ किस्सा है वो कल रात को देखा था. So like that, if you just search in the nearby peers, उनकी caches में छोटे छोटे टुकड़े मिल जाएंगे और वीडियो रिक्वेस्ट जो है बहुत दूर न जाते हुए पूरा जो है नियर बाय peers में से कलेक्ट करके वीडियो जोड़ के दे देगी. Now it has its own ways of counting the frames. Yeah, every frame is numbered, and I know I'm looking for frame number 1, frame number 2, frame number 3. Is asking me directly frame number 10. कोई बात नहीं, अगर नियर बाय किसी peer के पास frame number 10 है वो लाके दिखा दूंगी करके. It tries to minimize the traffic. So given the prominence of internet video streaming, we'll explore video streaming in depth later, but basic properties तो right now हम लोग करेंगे. Now important the techniques that they use is client buffering. When I buffered, आज मैंने वीडियो देखा है कहीं ना कहीं मेरी लैपटॉप या मेरी होस्ट में वीडियो का थोड़ा सा किस्सा कैश पे पड़ी है. So when you just open the YouTube, you can see that for 15 days I've been watching the video YouTube continuously. When I put the search, it pretty easily gives the search that I was trying to do from past 10 days, and the search phrases also will have what my friends in the near vicinity were trying. So all the people very near vicinity में जो phrases वो लोग try कर रहे हैं वो वीडियो बड़ी जल्दी मिल जाती है मुझे. Only the phrase which I rarely use that requires some time to search. So therefore client buffering is one technique. Prefetching यानी कि मैंने एक प्ले कर रही हूँ तो एक ही लाएगी ऐसा नहीं है, 10 फ्रेम लाके वो बफर कर देगी. It does prefetching. So therefore मानो बीच में इंटरनेट चली भी जाती है तो I know my video continues for some more time, maybe 10 मिनट तक चलेगी. I will be testing saying that why इंटरनेट चलने के बाद भी ये वीडियो चलती है. If I go back, वो तो बड़ी आसानी से चल जाती है. If I go little forward, वो भी बड़ी आसानी से चल जाते हैं. क्यों? I did a prefetching here and I stored something, I buffered something. And the other technique is it adapts the quality. So it just adapts to the rate according to the bandwidth that I am available. And content development network is another technique. So I don't allow the most of the responses to travel very far. I try to get it from the vicinity. Either I get it from the nearby peers or I try to fetch it from the content development network.